Okay, hey everyone. This is hopefully going to be a helpful review of topics for test 3, covering chapter 4 and the beginning of chapter 5. Basically going to go through the review packet. I know that we've already covered a lot of stuff in the review packet from our little Jeopardy game or whatever it is that we do, but I think it's helpful just to have it recorded so you guys can refer back to it. So, um, here we go. I'm just going to work through problems in the packet and some homework problems, basically. So, number one. So it says you have a 50-50 chance of choosing the correct answer. And we're supposed to express the indicated degree of likelihood as a probability value. So, trying to get you used to reading English and coming up with, you know, the math or statistics terms that um, we can just write out. So, 50-50 chance of choosing the correct answer. The probability of getting the answer correct, I guess one might write, is 50%, or 0.5, or 1/2. These are the three different ways we're going to write probabilities. Fractions are very nice for certain reasons. Percentages, I don't usually write probabilities. Usually I either write probabilities like this or this. Fractions or decimals. There's a 40% chance of rain tomorrow. It means the probability of rain is 0.4. You cannot determine the exact decimal number of pi. So probability of determining pi, if we cannot do it, then it's 0. So this is also the concept that probabilities must be between 0 and 1. If you think about saying that the probability of getting heads when you flip a coin is 2, or probability of getting tails when you flip a coin is -3, those numbers don't make sense when you're talking about probabilities. I mean, how is it possible to have a 200% chance of getting heads? So the least you could have for a probability is 0. That's if something cannot happen. It will definitely turn dark tonight. Well, just the opposite. The probability of it turning dark, since it's definite, since it's sure to happen, is 1. That's the most that you can have for a probability. Um, I mean, I guess if we were to say something like the probability of it being dark was 3, that means tonight it's going to be dark 3 times or something. It just doesn't even make sense. All right, you have a 1 in 10 chance of winning the race. So the probability of winning the race is 1 out of 10, or you could write 0.1, or you could write 10%. Again, you don't have to write equals 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 like I'm doing. I'm just doing it to show you that any one of these answers would be fine. Um, the actual answer in the packet is uh, C, which is a decimal. Um, Number 6. Which of the following cannot be a probability? So, just like I've been talking, a probability has to be between the probability of any event has to be between 0 and 1. So, since D is -1, then the answer is D, because you can't have a negative probability. You can't have a probability that's greater than 1, so C is 5/3, so the answer is C. What is a probability event that is certain to occur? So a certain event is 1. On a multiple choice test with 4 possible answers for each question, what is the probability of answering a question correctly if you make a random guess? Well, there's 4 possible answers. They're all equally likely. So a random guess is going to be 1 out of 4, which is D. And 8 was C. A sample space consists of 38 separate events that are all equally likely. What is the probability of each event? So if I were to write out the sample space, then I have I don't know, uh, event 1, event 2, I suppose, and so on. And I have 38 events, and they're all equally likely. So what's the probability of event 12? Well, it's 1 out of 38. So, if, what's the probability of each one? If I were to, of any of those events, since there's 38 of them, it's 1 out of 38, which is B. It didn't have to be event 12. I just picked a random one just to make the point. So, on a multiple choice test, each question has 6 possible answers. If you make a random guess on the first question, what's the probability that you're correct? This is, again, just common sense. 1 out of 6, because there's 6 possible choices. A die with 12 sides is rolled. What is the probability of rolling a number less than 11? This is number 12. So you have 12 sides. They're all equally likely. The probability of less than 11. This is important. Not if it said less than or equal to, that would give me a different answer. But since it's less than 11, I can get a 1, I can get a 2, I can get a 3, I can get everything up until a 10. So there's 10 possibilities, and I'm sorry, there's 10 ways of getting what I want, but there's 12 total possibilities. So 10 out of 12 or 5 out of 6, which is A. A bag consists of 6 red marbles, 3 blue marbles, 5 green marbles. If a marble is randomly selected from the bag, what's the probability that it's blue? So 6 red, 3 blue, and 5 green. If a marble is randomly selected, what's the probability it's blue? So the probability of being blue is going to be there's 3 blue, and there's that many total possibilities, which is really 3 out of 14, which is C. There are 2 6-sided die that are rolled. What's the probability that the sum of the 2 numbers on the dice will be 3? Now, I know you guys have done this on Khan Academy, quite a few of these, but I'll go ahead and make this table, which I think is helpful for these problems. Die 1, die 2. So we write out all the possible faces for die 1, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, good. So we're taking the sum of these. So 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, 12. These are all the possible sums. And I have a total possible sums are going to be 6 times 6, which is 36. So, what's the probability that the 2 numbers on the dice will be 3? Well, how many ways are there of me getting a 3? Well, the first die could be a 2, and the second one could be a 1, or the other way around. So there's 2 ways of getting a 3, but there's 36 total possible answers. So it's 2 out of 36, or 1 out of 18, which is B. So it takes a little bit of organizing your thoughts, but that's the best way I could see to do those dice problems. All right, so a spinner. This is number 15. A spinner has equal regions numbered 1 through 15. What's the probability that the spinner will stop on an even number or a multiple of 3? This is a good one. So there's 15 possible regions. So our sample space is 1, 2, all the way to 15. So we want the probability of an even number or a multiple of 3. So we write this as the probability of being even plus the probability of being a multiple of 3 minus the probability of both. And this is the kind of a formula that we went over, but I was explaining with Venn diagrams that when you're adding probabilities, sometimes there's an overlap. So there's all the even numbers, and there's the multiple of 3, but then there's some overlap there. So from numbers 1 to 15, my even numbers are 2, 4, 6, 8, 10, 12, and 14. But my multiples of 3 are 3, 6, 9, 12, and 15. So how many even numbers do I have? I have 1, 2, 3, 4, 5, 6, 7. So 7 out of the 15. How many multiple threes of 3 do I have? 1, 2, 3, 4, 5. But you notice how I counted. When I counted the 6 and the 12. I counted them twice. So now I subtract the overlap. I subtract that away. So there's the 6 and the 12 are both even, and they're both a multiple of 3. So I subtract away those 2. And we end up with 12 out of 15 minus 2 out of 15, which is 10 out of 15, which is 10 divided by 2 is, not 10 divided by 2 out of 5. Why was that so difficult? Okay. No, that doesn't work. 10 divided by 5 is 2 out of 3. Ugh. 2 out of 3. Okay. So it's B. But this is important to just think through the problem and say, okay, make sure I'm not double counting some of my events, I guess. Let's see, number 16. The table below describes the smoking habits of a group of asthma sufferers. So we have this table here. If one of the 1156 people, that's the total number of people, is randomly selected, find the probability that a person is a man or a heavy smoker. So this is more of this stuff that I was talking about, where you have to think about overlap and subtracting away when you're adding probabilities, because this statement of being a man or a heavy smoker means you could be one or the other or both. So what's the probability of being a man? Well, these are all of the men. There's 601 total men. What's the probability of being a heavy smoker? Well, these are all the heavy smokers. There's 88 total heavy smokers. So here we would write in number 16, the probability of being a man or heavy smoker is equal to the probability of being a man plus the probability of being a heavy smoker minus the probability of both being a man and a heavy smoker. So how many men do we have? Well, we have 601 out of 1156 total people. And I was told 1156 was the total right here, 1156. Also, the probability of being a heavy smoker is 88 out of 1156. Minus the probability of being both a man and a heavy smoker is going to be this number right here. See? This is all of the men who are also heavy smokers. So there's 49 of those. So that's 49 out of 1156. So I use the calculator and I do 601 plus 88 minus 49 divided by 1156 is going to give me 0.55, 0.554 if I round off, which is B. All right. Let's see. I think we've done enough of those overlap ones. Maybe let me do number 18. A card is drawn from a well-shuffled deck of 52 cards. Find the probability of drawing an ace or a 9. So that's going to be the probability of drawing an ace plus the probability of drawing a 9 plus the minus the probability of both, again, so we don't overlap. But sometimes we think about it and we're like, wait, what's the probability of getting a card and it's both an ace and a 9 at the same time? And that's not possible. There's no card that's like that. So you just have to add up, well, there's 4 aces in the deck out of the 52, and there's 4 nines in the deck out of 52, so it's just 8 out of 52, which reduces to 2 out of 13, which is D. Alright, and then number 20. So evaluate the expression 3 factorial. We should know by now is 3 times 2 times 1, which is 6. Number 21, 8 permute 4 is going to be 8 factorial over 8 minus 4, which is 8 times 5 times 7 times 6 times 5, all the way down until 2 and 1. And then this is 4 times 3 times 2 times 1. So this is going to cancel, and I'm just left with these first few numbers. So that just turns out to be 1680, which is A. Now, of course, there is that option in the calculator where you could just go straight to, you just hit 8 and then go straight to math and then probability, hit NPR and then hit 4, and then you get 1680. Either way, it's a multiple choice test for the most part. Okay. 10 choose 3. We should be familiar with these functions. It's more important that we know what they mean. But this one I'll just use the calculator. So we do 10 and then we do math, probability, choose 3. We get 120. And this would be the number of ways of having 10 objects or 10 people and choosing 3 of them without worrying about arrangement. And that's C. Here we go, and we're going to use these problems right now. There are 8 members on a board of directors. If they must form a subcommittee of 6 members, how many different subcommittees are possible? So we have 8 people. Person 1, person 2, or let me give them names. How about Bob, Jane, Billy, whatever. 8 people. And then last person is Tyrone. I don't know. So out of these 8 people, we're forming a subcommittee of 6. So 8. Now let's think about it. Does it matter the order? If it's a subcommittee, there's no rankings or anything like that. If it was choosing a president, a vice president, a board of director, then this becomes a problem where we're concerned about the arrangement, because you would have a certain slot for the president, a certain slot or seat for the vice president, a certain slot for the treasurer, and so on. So having Bob here, Jane here, and then Billy here is different than another arrangement of that. But That's not the problem we're doing. We're just forming a subcommittee. So out of the 8 people, we just want to choose 6 of them and be done with it. So go to our calculator and we do 8 math probability, choose 6, and we get 28. So there's 28 different subcommittees we can get. So number 28 is B. Actually, let's do number 25. How many 3-digit numbers can be formed using the digits 1, 2, 3, 4, 5, 6, 7 if repetition of digits is not allowed? So this is a good problem to do the slots. I'm allowed to use the numbers 1, 2, 3, 4, whoops, 5, 6, 7. So I have 7 choices for the first slot. But I can't repeat numbers, so that leaves me with 6 for the second, and then 5 for the third. So that's 210 if I multiply these all out. Okay, so that's D. Number 27. There are 6 members on a board of directors. Now here they have to select a chairperson, a secretary, and a treasurer. How many different slates of candidates are possible? This is when it becomes a permutation problem. So we have 3 people to permute, or 3 different positions we can permute out of the 6. So this is no longer a choose problem because now the order of the people matters. If I have Bob and Billy here, that's different than having Billy and Bob in a different order. So 6 math probability permute 3 is 120. So I have 120 different possibilities, which is D. Okay, and let's do number 29. It says 12 wrestlers compete in a competition. If each wrestler wrestles one match with each other wrestler, what are the total number of matches? So we've got 12 wrestlers. So let's imagine that one of the wrestlers is Mr. Rodriguez. Okay. How many other guys am I going to wrestle? I'm going to wrestle 11 other guys. And if I drew 11 lines, you'd see. But clearly, I'm going to wrestle 11 other guys. So each guy out of the 12 wrestlers is going to wrestle 11 other guys. So if I multiply those out, I get 132. But if I think a little bit more about it, the question is, how many matches are there going to be? So one match takes care of Mr. Rodriguez wrestling The Rock and and then that also takes care of The Rock wrestling Mr. Rodriguez. So you have 2 things being taken care of at once, and then you divide. So you can divide that number by 2, since that's the number of matches that you would have, since you wouldn't have a separate match for Mr. Rodriguez wrestling The Rock and then another one for The Rock. That would take care of both matches at once. So this number is twice as big as it needs to be. So this should be 66, which is D. Okay. There might be a homework problem that we can work on, but actually that packet was pretty good. Let's see. Um, so just some definitions to remember maybe. Um, that the basic idea of probability of an event is the number of ways that the event can occur divided by the total number in the sample space. So your book has it written as the number of elements in the event and the number of elements in the sample space, because the way we think about this is the sample space is the total, is all possible outcomes. So and then all outcomes is one word. And then the event is a subset of this. So then we count and we divide. And that's why all this stuff with the choose and the permutation was so relevant, because we have to count things efficiently and think of ways of just, not having to literally list out every single occurrence. Another thing is that if I were to add up all of the events in the sample space, they all should add up to 1. All of the what's called the simple events, I guess, they shall add up to 1. So this is the definition of a probability distribution. And then, of course, remember that every probability can only be between 0 and 1. That's it. I think that's a pretty good review right there. So good luck studying for the test.